Hello, welcome back to Electrical Power Generation and Economics. In this video lecture, we are going to study about economic dispatch. Mainly, we are concentrated about the economic generation of power. Generator cost curve. The first topic is our generator cost curve. Generator cost curves, or simply generator costs, are typically represented by following four different curves. The first one is your input output curve, input output curves. The second one is your fuel cost curve, that is fuel cost curve. The third one is your heat rate curve, that is heat rate curve. And the fourth one is your, which is very important among these four, and that is incremental cost curve, that is incremental cost curve. Before explaining all these 4 points of generator cost curve, let me give you some points for reference. Just for reference, I am giving you few reference points for will be very helpful while having calculation for numerical, that is for reference. The first one is your 1 BTU, that is it is written as capital B small t small u, and the full form is British thermal unit. British thermal unit, which is equal to 1054 joule. One mega BTU is equal to 1 into 10 raised to power 6 BTU. The next one is 1 mega BTU also equal to 0.293 megawatt hour, and also 3.41 mega BTU is equal to 1 megawatt hour. Please keep all these points in mind, and we are going to start first topic, input output curves. Input output curves. What is that? This is your y-axis and this is your x-axis. In the x-axis we have taken generator power. We have taken generator power in megawatt. In y-axis we are going to take input output in the unit is mega BTU per hour. Mega BTU per hour. Let us say this is your origin and this is the scaling of this input output in the unit of mega BTU per hour. Let us have different color to understand it better. That is, if the curve be like this and it is the input output curve plots this curve plots fuel input in mega BTU per hour versus net megawatt output versus net megawatt output. So input output curves simply says by its name also that is it is a curve that plots fuel input in mega BTU per hour versus net megawatt output. That shows the variation of generator output with respect to fuel and fuel in terms of mega BTU per hour. Let's have the second fuel cost curve. The second fuel cost curve is fuel cost curve, which is input output curve. Fuel cost curve is input output curve scaled by fuel cost. Fuel cost. That is, a typical cost for coal is, let's say, a typical cost for coal as fuel is, let's have in dollar, the international currency, 1.75 per MBTU, and this be like this is generator power in megawatt, and this is fuel cost in dollar per hour. The y-axis is our fuel cost that is fuel cost in dollar per hour. Let this be origin. If the curve is like this, it is not starting from zero. See this. If the curve is scaled by fuel cost, the curve of input output curve scaled by fuel cost, this is your fuel cost curve. The next one is your heat rate curve. The next one is your heat rate curve. What is that? That is point number 1. It plots the heat rate curve. The heat rate curve plots the average number of the average number of mega BTU per hour of fuel input needed per megawatt of output. Needed per megawatt of output. Also, this is the input output curve. This is the input output curve scaled by megawatt. Keep this in mind. This is the input output curve scaled by megawatt output. Let us have the diagram, the curve. The curve be like this is your y-axis in the y-axis, and this is your z-axis, sorry, x-axis. So this is your generator power in megawatt, and this is your heat rate. In the y-axis we have taken heat rate in the unit of mega BTU per megawatt hour. Let this be origin. This is the graph. That is if this is a 100 unit of megawatt generator output, if this is a 200, if this is a 300, and if this is a 400, and this is a 8 unit, and this is The y-axis is your heat rate and the unit is MBTU per megawatt hour. If this is your 10 unit and this is your unit 12.0 something, so this shows that it is something like 13, around 13. Base for most efficient units are around 13. That is, this point is showing best for most efficient units are just within 12, that is 13, as shown here. This is a typical example. It could be anything. This is just shown to make you understand how it is actually taken into practical account. The next one is, which is going to serve a wider role in your economic of power system is concerned. As far as economic generation of power system is concerned, that is your incremental cost curve. That is your incremental cost curve. That is also known as marginal cost curve. As the name incremental or increment is itself showing, that is something there has to be deal with d by dt rate. Let us see. This is the plots. This is a kind of plots which plots the incremental, dollar per megawatt hour as a function of megawatt. This is our generating power unit. And how it is get, and how it is got. It is found by differentiating the cost curve. It is found by differentiating the cost curve. Differentiating the cost curve. Let us see the diagram. The curve actually let us take y-axis and x-axis. This is your x-axis and this is your y-axis. In the y-axis we have incremental cost. In the y-axis we have incremental cost. The unit of incremental cost is dollar per megawatt hour. And this is your generator power in megawatt. This is your origin Now let this is 5, this is 10 unit, this is 15 unit, and this is somewhat 20 unit. This is 100, let us say. This is 200, let us say, and this is 300, let us say, and this is 400, let us say. Now, if it is like this, if it is like this, see this, this kind of plot incremental versus generator power is called your incremental cost curve. Now let us move for the mathematical formulation of cost. Let us move for the mathematical formulation of cost we have studied right now. Before going to formulate the mathematical formulation of this cost, let us have some key points. Point number one. Point number one is generator cost curves are usually not smooth. Generator cost curves are generally or usually not smooth. Okay. However, nevertheless, the curves can usually be adequately approximated using piecewise smooth functions or some kind of functions. It could be made adequately approximated using piecewise smooth functions or any kind of functions you assume would be beneficial to make it adequately approximated. Now, the representation of the mathematical formulation of cost, representations, which is predominant by first one is your quadratic form of function, or second one is your cubic functions. The first one is more common and it is widely used for the representation of mathematical formulation of cost, and the second one is your, and the next one, third one is your piecewise linear functions. That is your piecewise linear functions. we'll understand and we will look into deep of piecewise linear functions in some other videos, because this is not the scope of to learn the piecewise linear functions of this video. In this video we are just going to concentrate from this point of time the mathematical formulation of cost. We are going to understand how the cost is formulated mathematically. Unless we do that, we are not going to help ourselves as far as being power engineer is concerned. Let us consider cost functions Ci. This is Ci, cost function of power generation ith generator is equal to alpha ith plus beta generator power of ith generator plus gamma p square gi in dollar per hour. That is your fuel cost. Now, as we have studied earlier in this video, that the incremental fuel cost is achieved or found just by differentiating the cost curve. If this is your cost curve, just differentiate. After differentiating, we'll get incremental fuel cost ith of power generation of ith generator is equal to d by dPgi. That is, we are differentiating this cost curve with respect to power generation of ith generator. That is, we are differentiating this equation number 1. So just differentiate this equation number 1 with respect to PGI. What we will get? This is our constant. We will get beta plus twice gamma power generation of ith generator dollar per megawatt hour. This is your incremental cost function of power generation of ith generator. Now let us have quick revision of this section. This is your cost functions of ith generator. This generator is generating power PGI, that is in quadratic terms, in quadratic functions, that is alpha e plus beta PGI plus gamma p square gi. Now to get incremental fuel cost or marginal fuel cost, just differentiate this cost curve with respect to power generation. We will get ICI PGI is equal to, this is our incremental fuel cost, is equal to beta plus 2 gamma PGI. That's all in this video. We'll have